Dear friends, as many of the stars like the sun are providing us with constant light or energy, but their brightness varies by only 0.1% over years and decades because of the fusion of hydrogen into helium that powers them. This process will keep the sun shining steadily for about 5 billion more years, but when stars exhaust their nuclear fuel, their deaths happen. Eventually, the sun will get big and then shrink into a tiny star called a white dwarf. But stars heavier than 8 times the sun explode in a big bang called a supernova. Supernovae happen across the Milky Way only a few times a century, and these explosions are usually remote enough that people here on Earth don't notice. For a dying star to have any effect on life on our planet, it would have to go supernova within 100 light-years from Earth. Only a small number of stars are big enough to go boom in a supernova. But when they do, they shine bright as billions of stars combined. With one supernova happening roughly every 50 years and considering there are 100 billion galaxies out there somewhere in the universe, a supernova pops off about every 100th of a second. When a star is on its way out, it shoots out super strong radiation called gamma rays. These rays are a kind of invisible light that's way shorter than what we can see. The star also throws out a bunch of speedy particles called cosmic rays. They're tiny particles zooming around almost as fast as light. Supernovae in the Milky Way are rare, but a few have been close enough to Earth that historical records discuss them. In 185 AD, a star appeared in a place where no star had previously been seen. It was probably a supernova. Observers around the world saw a bright star suddenly appear in 1006 AD. Astronomers later matched it to a supernova 7,200 light-years away. Then, in 1054 AD, Chinese astronomers recorded a star visible in the daytime sky that astronomers subsequently identified as a supernova 6,500 light-years away. About 600 light-years away from us, there's this huge star called Betelgeuse in the Orion constellation. It's one of the closest really big stars to us that's almost done for. When it eventually explodes in a supernova, it'll be as bright as a full moon in the sky for us here on Earth. But it won't hurt anyone or anything. But if a star blows up real close to us, like within 100 light-years, the gamma rays it shoots out could mess with the protective stuff that keeps life safe on Earth. Plus, because light takes time to travel, we won't see it until 100 years later if a supernova happens 100 light-years away. Scientists have found proof of a supernova that happened 2.5 million years ago, about 300 light-years away. They discovered radioactive stuff in the sediment at the bottom of the ocean, which is a clue about this explosion. When the supernova happened, the gamma rays it released damaged the ozone layer, protecting us from the sun's harmful rays.
This messed with the climate and probably caused some ancient creatures to die out. Being far away from a supernova is safer. When a supernova goes off, it sends out gamma rays and cosmic rays in all directions. So the farther away it is, the less of these rays reach Earth. For example, if there were 2 supernovae, one 10 times closer to us than the other, and the one closer would hit us with radiation about 100 times stronger. If a supernova exploded close by, within 30 light-years, it would be really bad news. It could mess up our ozone layer, which shields us from the sun, mess with ocean life, and might even wipe out lots of species. Some scientists think that supernovae nearby caused a bunch of creatures to die out around 360 to 75 million years ago. Fortunately, these kinds of explosions happen close to us only once in a long while, like every few 100 million years. But it's not just supernovae that shoot out gamma rays. When neutron stars crash into each other, they make all kinds of powerful stuff, from gamma rays to gravitational waves. When a star explodes in a supernova, it leaves behind something called a neutron star. These are tiny, like the size of a city, but super heavy, way denser than the sun. When 2 of these neutron stars crash into each other, it's like a big squeeze that pushes their atoms together. This process makes valuable stuff like gold and platinum. So, many of the precious metals on Earth came from these intense collisions in space. When 2 neutron stars crash into each other, they release a big burst of gamma rays. These rays shoot out in a tight beam, packing a powerful punch. If Earth were in the path of these gamma rays from a collision within 10,000 light-years away, which is about 10% of the galaxy's size, it would mess up our ozone layer and even harm the DNA inside living things' cells. This could kill off a lot of simple life-like bacteria. But don't worry too much. Neutron stars usually don't come in pairs, so these collisions only happen in our Milky Way galaxy about once every 10,000 years. They're much rarer than supernova explosions, happening only about 100 times less often. But across the whole universe, neutron star collisions happen every few minutes. Gamma-ray bursts might not pose an immediate danger to life on Earth, but eventually they'll hit us. Looking back over really long times, there's been a 50% chance of a gamma-ray burst causing a mass extinction in the last 500 million years, and a 90% chance in the 4 billion years since life began on Earth. So, it's possible that one of these bursts caused one of the 5 big die-offs in the past 500 million years. Some scientists think a gamma-ray burst might have caused the first big extinction 440 million years ago, wiping out about 60% of sea creatures. The radiation caused a sudden disturbance to the Earth's ionosphere, even though the source was an explosion nearly 2 billion light-years away.
Life on Earth was unaffected, but the fact that it altered the ionosphere is sobering. A similar burst in the Milky Way would be 1,000,000 times brighter. This is today's discussion. Thanks for watching the video.